Venture outdoors this instant. Proceed to the nearest planter, that ancient stone slab, or that fragment of timber that has been idly occupying a corner of your property for a considerable duration. Lift it. What you discover concealed beneath will almost assuredly contain them. Tiny, ashen, encased in a natural shell, exhibiting movement in all directions simultaneously, and at least a portion of them instantly coiling into immaculate spheres the very moment illumination touches them. Dozens of them, occasionally hundreds, massed together within the cool, shadowed recess beneath the object, entirely unperturbed by the world above. Your immediate inclination, if you conform to the general populace, is to reinstate the planter or to procure an implement to eradicate them. They present the appearance of a nuisance. They appear as something that has no place in a thriving garden. However, here is the understanding I implore you to gain before you take any further action. What you are observing is not an infestation. It is not an indicator of neglect, decay, or any adverse development within your garden. What you are observing is one of the most industrious, chemically sophisticated, and profoundly misunderstood organisms within your entire outdoor environment. And the day you cease your efforts to eliminate them is the day your garden experiences a measurable enhancement in its vitality. Today, we will delve into the true nature of what are commonly known as roly-polies, scientifically designated as Armadillidium vulgare, and more formally as pillbugs. We will explore not their outward appearance, nor the instinctive fear they evoke, but rather their actual identity, their actual functions, and the reasons why the truth about them is so astonishing and so beneficial that most individuals, upon hearing it, feel an immediate urge to share it with another. Let us commence with a revelation that will fundamentally alter your perspective. The roly-poly is not an insect. Reiterate that to yourself. It is not an insect. It shares no kinship with beetles, ants, or any of the other subterranean inhabitants we typically associate with garden soil. The pillbug is a crustacean. It belongs to the order Isopoda, the very same biological classification as shrimp, crabs, lobsters, and barnacles. It is, in the strictest taxonomic sense, a terrestrial crustacean, a relative of those creatures you might order at a seafood establishment, which, over epochs of evolution, transitioned from the ocean to make its habitat in the earth beneath your garden planters. I distinctly recall the initial moment I encountered this information in a scientific publication, necessitating a pause and a rereading of the text. A crustacean inhabiting my garden, a member of the same family as the lobster gracing someone's dinner plate, residing beneath a terracotta pot adjacent to my tomato plants. It is the sort of fact that initially feels improbable until one closely examines the creature itself, and suddenly, its segmented armor, its numerous pairs of appendages, and its mode of locomotion coalesce into a coherent and entirely different understanding. This solitary fact, that it is a crustacean and not an insect, unlocks the comprehension of all the remarkable aspects of its behavior. Because crustaceans originated in aquatic environments, their biological makeup was intrinsically suited for water-based existence. And when the progenitors of the pillbug embarked on their migration to land, a process that spanned tens of millions of years and necessitated extraordinary physiological adjustments, they retained certain biological mechanisms developed for water. These mechanisms, within the terrestrial environment of the soil, evolved into unique capabilities unmatched by any other land-dwelling organism. The pillbug respites through specialized structures known as pleopodal lungs, which are essentially modified gill-like organs located on its ventral surface that require constant moisture to function. This is the fundamental reason for their congregation in humid, dimly lit locales. It is not a matter of preference, but of imperative survival. Biologically speaking, they remain partially aquatic, intrinsically linked to moisture in a manner analogous to their oceanic ancestors' reliance on water. However, this aquatic lineage has bestowed upon them an extraordinary compensatory advantage. Pill bugs are detritivores. Their sustenance comprises decaying organic material, fallen leaves, decaying wood, fungi, and the decomposing remnants of other organisms. In performing this role, they execute one of the most vital functions within any garden ecosystem. They break down organic matter into forms amenable to further processing by soil bacteria and fungi, thereby expediting the decomposition cycle that yields the essential nutrients your plants require for growth. A garden populated by a robust community of pill bugs exhibits accelerated decomposition of its organic waste, more efficient nutrient recycling, and superior soil structure compared to a garden lacking their presence. This characteristic alone would render them worthy of protection. Nevertheless, it is not the most astonishing aspect of their functionality. The most remarkable capability, which has been the subject of intensive scientific investigation for the past 2 decades, pertains to their interaction with heavy metals present in the soil. Lead, cadmium, copper, zinc, arsenic. These toxic metallic elements accumulate in urban and suburban soils due to decades of industrial operations, emissions from vehicles, antiquated paint formulations, treated lumber, and contaminated groundwater. They do not degrade. They do not dissipate. They accumulate in the soil, are absorbed by plant tissues, and ascend the food chain into the produce you cultivate, into the organisms that consume them, and ultimately, into yourselves. Pill bugs ingest contaminated soil material, and when this occurs, an extraordinary transformation takes place within their bodies. Research disseminated in the journal Cell Biology International has identified specialized cellular structures within the pill bug's midgut termed S cells, which actively extract heavy metal ions from ingested matter and sequester them within mineralized spheres. These metals are not metabolized. They are not re-released into the soil. They are permanently immobilized within the pill bug's physiology, effectively removed from the soil ecosystem and stored in a form that precludes re-entry into the food chain. The pill bug does more than merely inhabit your soil. It purifies it. By any scientific metric, it stands as one of the most effective biological agents for the remediation of heavy metal contamination ever identified, operating continuously and gratuitously in precisely the areas where such pollutants concentrate. Investigations conducted at academic institutions across Europe have revealed that pill bug populations found in contaminated urban soils contain demonstrably higher concentrations of lead and cadmium than the surrounding soil matrix, indicating that these creatures are actively extracting these toxins from the environment and concentrating them within their own organisms. When these organisms perish and are consumed by other decomposers, the metals are transferred further up the food chain in a contained, mineralized state, exhibiting significantly reduced bioavailability compared to the free ionic metals present in contaminated soil. Your pill bugs are actively engaged in a detoxification program within your garden, while the majority of people are inadvertently crushing them. However, there exists another dimension to the pill bug's biological makeup that warrants particular attention, and it is this aspect that elucidates the characteristic rolling behavior from which they derive their most widely recognized appellation. The defensive coiling is not merely a reactive behavior triggered by perceived danger. It represents a triumph of structural engineering. The exoskeleton of the pill bug, composed of overlapping plates that confer its segmented, almost mechanical appearance, is meticulously designed to interlock precisely when the organism curls. The resultant form is a sphere devoid of exposed soft tissue, possessing no vulnerable points of entry and a surface that disperses external pressure uniformly across the entire structure, rather than concentrating it at any single location. Engineers at various universities have studied the pill bug's rolling mechanism as a paradigm for the development of flexible, impact-resistant structures, applicable in fields such as robotics, protective gear, and aerospace components. The creature that people often tread upon in their gardens possesses a bodily architecture so sophisticated that it inspires research in aerospace engineering. This is the entity residing beneath your garden planters. Not a pest, not a problem. A terrestrial crustacean with an evolutionary history spanning 300 million years, a respiratory system based on modified gills adapted for subterranean life, a digestive process that enhances nutrient cycling, a mechanism for sequestering heavy metals that safeguards your soil and your food supply, and a structural defense system that has stimulated advancements in contemporary engineering. The most pragmatic insight you can glean regarding pill bugs is this: they flourish under appropriate conditions, and their presence signifies a factual characteristic of your garden. They necessitate moisture, organic material, and darkness, which are precisely the conditions that foster healthy decomposer communities, populations of earthworms, and the intricate fungal networks that nourish your plants. A garden exhibiting hundreds of pill bugs beneath its planters and stones is indicative of soil that is alive, active, and biologically rich. Conversely, a garden devoid of them often suggests an environment that has been subjected to excessive treatment, desiccation, or a depletion of the organic matter essential for their survival, and consequently, for your soil's optimal function. If your intention is to support them, and compelling scientific rationale now exists for such a course of action, the approach is straightforward. Maintain a surface layer of organic matter in your soil, such as leaf litter, wood chip mulch, or the remnants of vegetation from previous seasons. Ensure consistent moisture levels. Cease the application of broad-spectrum pesticides that eliminate organisms indiscriminately. And the next time you lift a planter to discover them present, gently return it to its position. They were engaged in a significant task within the darkness, and they will resume their endeavors the moment the light recedes. The next time an individual within your household reaches for footwear near the garden, inform them of what they are about to encounter. Not a pest, not a nuisance, but a crustacean that has been diligently purifying your soil, filtering your contaminants, and quietly, continuously, and without any expectation of recompense, building the foundation of your garden's health. Have you ever uncovered hundreds of them beneath a planter or a stone and pondered their activity? Share your experiences in the comments section below. I meticulously review every contribution, and this community is home to some of the most compelling garden narratives I have ever encountered. And if you wish to deepen your understanding of another organism that is presently performing indispensable, unseen labor within your garden, one that most individuals have never considered investigating, the subsequent video is already accessible to you.